Welcome back, everybody, to Scale Success with Reptile Podcast. Big episode for myself. It's number 50. It's just been grinding over the last 2 years with the podcast. So pretty excited to get to this number. Looking forward to the next 50. But, for this one being the 50, I wanted to make it something unique, something special, and bring in a panel to talk about something that has been a combo that has been, been throwing a couple of breeders for a loop or different. We've seen some weird outcomes on some pairings. Was the perfect one to make it for the 50. And then the panel that we have tonight, they're all very well known within the reptile industry, specifically some in the hognose, and then bringing on somebody that has actual training and education on genetics was a big part of it. So real quick before we get onto it, just a quick update of what's going on in our world. So we have this weekend, we have a local show here in Florida. So we got a Repticon in Orlando. So you guys are in the area looking for a hognose, just want to come talk hognose or want to talk a little bit more about this episode. If you have any other questions, stop by the table and we'll definitely be there. We've vended with Being Little Reptiles, have some ball pythons, and Paul for Real 3D has all the 3D models of different reptiles and stuff like that. So stop by our tables and definitely talk some reptiles and about the hobby. We got that going on. And this week we'll be dropping our first set of 2025 available hatchlings on our morph market. The Patreon members already got a list. So you guys, if you guys ever want a sneak peek of what we got going on the breeding season, make sure to join the Patreon. So those guys already they already get the first picks and they got a list of it. So pretty cool to see that. Interesting. And one of the main reasons I was put this thing together was because I finally now experience the Frost combo complex and the interesting outcomes that come from the hatchlings out of these pairings. So, full circle coming around now, talking about it, having a little bit of experience, not much, but then bringing other people that do. Other than that, next couple of shows we're going to be in Daytona as well. I know as well as most of the panel here will be at Daytona in the RBC. So making sure you guys stop by, talk to us, and see what's going on. And then that's pretty much it for us. Breeding season's down to basically done. So now it's time just to get the babies eating, get them posted online. If you guys are looking for anything specific, make sure to DM us. And before we do get to it, I'm going to give a shout out to our sponsors and some important organizations in our reptile industry. So first, starting off, USARK Florida. If you are not a member of USARK Florida, make sure you go get a membership. Doesn't matter if you live or don't live in Florida, you need a membership for this as well. Florida is the spearhead that fights against any of these legislations that will be basically targeting our reptiles, our animals, starting here in Florida. And what happens a lot of times is laws that get passed in Florida trickle into the other neighboring states, and then it keeps just rolling out. So Florida is USARK Florida is very important to support. And if you guys are ever see an auction, make sure you guys bid on stuff from USARK Florida. And then USARK National, they're the nonprofit organization that nationally fights against any legislations or local laws that will affect our animals. And if you guys ever have any issues or have anything coming up in your local governments, make sure to reach out to USARK. Phil's always very involved in the reptile hobby. And then we have our Patreon. Of course, we started it this year. If you guys want to join, starting a real nice group there, getting information to each other, learning from each other. So really good group that we started. So make sure you guys go check it out after the show. The link is in the bio, in the description below. And our sponsorship is Sea Serpents. If you guys are looking for a rack or incubator, make sure you go message Chris or call him. He's usually the one that answers the phone. Great customer service. All my racks are from Sea Serpents, and great, like I said, great customer service, great product. Make sure you guys go out and check them out. We have Blake's Exotic Feeders. If you guys are looking to add a little bit of variety to your feeding schedule for either snakes, lizards, crocodilians, whatever it is, he has a wider variety of sizes, and he breeds contornics and button quails. So he has even small little quail for hognose, about say like 20-gram hognose that you can feed him and try a variety of a diet into your feeding regimen. And it's bred right on his farm directly to your doorstep. So there's no middleman. So you know the quality you're getting is top notch. And our partnership with Husbandry Pro, if you guys are looking to keep records of all your husbandry, take your record keeping to the next level, make sure to use Clover 60 for a 60-day free trial. And this has helped us in the long term a lot because it keeps track of all of our breedings, our incubation, our pairings, and then once an animal sold, the new owner gets all the information that has been inputted for the animal, and it stays in our records forever. So very important thing to have for us here. If you guys want to try it out, make sure you use Clover 60. So guys, we're gonna, actually we got a good amount of people here. I think this is such a big topic. So let's say hi to a couple people before we bring on the guest, and we'll be going there from there. Dickie Foster, thanks for joining. First time seeing you here. Thanks for joining in. Enchanted Hogs, thanks for joining in. Bobby Evans, good seeing you again. Dustin, how's it going, man? Lowtown Reptiles, thank you for all the support. Crystal, thanks for joining in. Hogalicious, how you doing? Thanks for joining in. John Carroll, Kaizen Hogs, how's it going? Thanks for joining in, bud. Mike Bradley, how's it going? Thanks for joining in. Sand Dragon Hogs, how's it going, man? JMG Reptiles, what's going on, Jeff? Thanks for joining in tonight. I know Jeff definitely has some information you could probably share in the chat as well. Got JNS Exotics, thanks for joining in. And guys, we're going to end it there. Make sure you guys subscribe to the channel. Hit the like button. Drop a comment down below. Drop a super chat if you want to support the channel. And we'll get here the episode rolling here in a few seconds. Welcome to the podcast, guys. You guys all have been on here. So again, thank you for joining us tonight. It was called try and play musical chairs, getting all this put together. But glad we have the panel we do for tonight.
Yes, glad to be here.
Yeah, thanks for having us, Alvaro. We appreciate you.
Man. Hey, thanks for this honestly, I'm just here to listen, really. I have John as an Exotic Firehogs and Ben. You guys are really the experts here. So, I'll give him my 2 cents and we'll go from there and see how it goes. If you guys want to give, first I want to preface this episode by saying, like, what we're going to go through today is theories, right? It's not a black or white answer, unfortunately, right? A lot of us will like to say, yes, is this one way, or like to have that answer to be able to figure it out. But this is why I did choose the panel, because we are here to learn from each other, here to share the knowledge that they do have. And, like I said, my limited breeding and frost this year have finally experienced the frost complex in my own collection. So John, starting off with you, and then Eslyn, and then Ben. John, just give us a quick overview of about how many frost parents you would say you have had, and what has thrown you off the most with this.
Well, we started breeding frosts, I want to say 9 years ago. We started out with actually some triple hets for sable, caramel, and hypo.
Mm-hmm.
So we acquired those. I want to say that the frost used for that pairing was from Mikel Klumpers from Europe, and it was bred to a sable, and we acquired 2.2 of the triple hets from that pairing to later make something everyone's heard about at this point in time called the permafrosts. So that is when we started that, and since we have made the visuals, we have went those animals back together, done other breedings with the frosts as well. We've bred those permafrost animals to different frosts, and got some interesting results. I mean, it's not following the same mode of inheritance as like you would say like a snow hognose snake or a mai tai or a sunburst or something. There are some curveballs that are thrown in there. So, Ben, you're a geneticist, so you will know the more technical terms on it. But I just feel like in my mind, rewind back to the late 90s, early 2000s. The first hypos came from Richard Evans from a gravid wild caught female, and he hatched the first hypos from that one, and then that started this line of animals that I want to say Mikel Klumpers had acquired some double hets of the PPA and hypo from Richard Evans in 2003, and he ended up making some all the visuals. So he made frosts, he made caramels, albino caramels, albino frosts in 2005. So that's where a lot of these genes started. That then therefore were plugged into a lot of other projects. But that's kind of the history of the frost itself, from what I understand. So
yeah, okay. And we're gonna go over too. Like, I'm gonna bring up what is basically what is the actual visual of each gene that we're talking about, so people have a an idea.
Yeah, that'll be good. So that you're going to bring a picture of that, or
yes.
Perfect.
So this is the Evans hypo, and here's the thing too. Once I started collecting some pictures from John, Eslin, and what I had in my collection, there's especially what John has sent, his hypos and caramel look a little different. And so that's one interesting point where we're going to bring up is that he looks different. Yeah.
Can I throw one thing in here while we're early on? The other thing, and let me know if you two have this same understanding, but it looks like when I was reading up on this, getting ready, but this Evans hypo is actually a T positive albino.
Yes.
So people call it hypo. It's been that way since the beginning, but it is actually a T positive albino.
Correct.
Yes. Yeah.
That will help with our discussion later on, I think, because like being allelic, hypo and albino being allelic, I don't know of that ever happening. But once I realized, oh, this is actually T positive albino, that changes things.
Okay.
So, and this is a caramel conduct from Eslin, right? I'm going to go through the couple pictures. Definitely. So caramel has that very distinct, very high white, what would I say, the walls, and then color in the middle. So that's another expression we're seeing in the frost as well, right, John?
Yes.
And then here we have a hypoconda from Eslin, where polygenics will throw off a little bit what we've talked about, but his look a little more reddish than what I have in my collection. We'll go through them, and then hypo looking belly. And then this is hypo and caramel from John's collection.
Frost.
Frost. Okay.
Caramel.
So this
yes.
is the frost, and then there's the caramel.
Correct.
Okay.
Okay.
And then the heads together pretty similar. So those are two base morphs that we're looking that combine to the frost, or at least what we're thinking is combining to create frost, right?
Mm-hmm.
So going from there, we get the double visual, the frost. And I'll bring a pairing of those up.
And while you're bringing that up, one other question for you, John. So when you got, how many triple hets did you get originally?
4.
And that was 2.2?
That is correct.
And those just looked like normal hog noses, but they were triple hets?
Normal hog noses, yep. And they were from a visual frost to from one of the original line sables. So that's where those first triple hets came from.
Okay. And then from those triple hets, you have produced all 3, the homozygous, sable, caramel, and hypo.
Yes, from those original ones. But the offspring, some of them do not produce some of those single recessive mutations at all.
Interesting. Okay.
So that's what's interesting.
Yeah.
Cool.
So here we have a Arctic superconda frost, and this is one of the animals that I hatched out this year. So has that reduction of pattern in the head, right? That grayish silver color in the body and the scales, and then has the zipper belly that we say with a darker purplish color. So that's where also we're differentiating frost from caramel, where we get the darker belly instead of the light belly, and the darker dorsal what was it called, scales and head pattern, right? We'll go through some of this. And here we have a Arctic conda frost albino. And then frost albino and Arctic permafrost from John. So same, what's it called? Phenotype looking animals. And here we have John's frost as well. And here is one of the question marks, where is it caramel? It is a frost pairing. So here's an anomaly that we're getting, right? Visual frost to visual frost. He gets frost, and then he gets this thing. It doesn't look like the frost. So is it caramel, or is it just a different type of frost?
And those parents, all they have is frost, just the caramel and the hypo?
Yes. So, well, one of the parents is an actual triple visual. So it's a sable, caramel, hypo. And then the other parent, they're both heterozygous for albino as well, but the other parent is a non-het sable.
Okay.
So it is not het sable at all. So I do just get these animals off of it, but I consistently make these caramel looking animals. They're not the albinos like you see above. I tried to get that picture with all 3 of them there. That's on the left.
Mm-hmm.
That way you can see the 2 variations of caramel or a frost, and then the albino version as well above it.
Interesting.
Yes. And I've spoke with Mikael Klumpers about that. He's produced, I don't know, he's been producing them since 2005. I couldn't put a specific number, but it wouldn't surprise me if he's been up there in the 500 to 1,000 range of frost caramel complex animals. And I spoke with him over the last year about this as well, just because I've been getting these interesting results over and over with these oddball animals. And he said he as well, when he breeds frost to frost, he will get frosts and caramels, never anything else, not a single gene hypo, when it should follow the simple rule like we've talked about before. You breed a snow and a snow together, you get snows. This is not the case. He does have these caramel type animals that pop up as well. But what I drew a diagram as well, and we can talk more about it. It may be, I don't know if I'm using the term correctly, allelic, like these genes may be allelic, but I think they fall like over a more it's not just like one side of the gene and the other side. It's not just those two things. I think it may be a set of these genes and how they are interacting with each other. And we may be getting, alternate versions of this frost when these things set up on this way, and then they pass that on to their offspring, whichever way that they are expressing the gene. So therefore, the caramel version of the frost maybe passes the genes of frost on different than the typical steel blue frosts that I make. Yeah. So they just may pass those genes on a little different. Yeah. So different phenotypes of the frost itself come from that. You see what I'm saying? That's why I'm saying there's different phenotypical variations of it that can float around. That's why you get the ones that look like that, and then the blue ones, and then some that are more typical, like gray. They look very drab and brown. I would say there's probably 5 different phenotypical variations of that set of genes there, in my opinion. Like I said, it's just a theory at this point in time. And what I've seen.
So all of those babies that we were just looking at are possibly het for sable.
No, they are 100% het for sable.
All het for sable.
Yes.
So that's the other thing. It's not like that, giving you some that are a different color because of that het influence. If they're all het, then that's not
correct.
So
correct.
Yeah. So the fact that
they're all proven
yeah, that's interesting. So the fact that you started out with 2 pairs of triple hets that looked normal, and you're able to produce all 3 recessive traits from those triple hets tells me that they're not allelic by that definition of, in breeding genetics. Mm-hmm. Those wouldn't be allelic because the fact that you can have triple hets that aren't compatible, you're not showing any kind of albino or any kind of, anything, then that's telling me those aren't on the same gene. But there's certainly, to me, it sounds like there must be an additional mutation that's, turning off and on that caramel. It's either overriding the bluish or grayish color, or somehow it's allowing the more caramel look sometimes and not others. Do you get it about a fourth of the time or half the time, or do you have a feel for that?
So I would say it happens every clutch from that specific pairing that I do. So that pairing acts that way. The offspring from that permafrost male, the triple visual, have never given me a hypo. The offspring from there. So they've only given me caramels, sables, and then the permafrost or triple visual, and frosts, but never hypo on its own. I've never experienced hypo on its own from any offspring from that permafrost animal.
And what does a hyposable look like? Is that noticeably different from a sable?
Yes. So we made those, I want to say the same year or year before of the permafrost, and we called that the oxide. And from that original pairing, we've made those and the toasted caramels as well. We made that the following year. So yes, we've made all of those.
Interesting.
Yeah, and I'll bring up this other pairing that John sent me as well. So this pairing was permafrost by frost, right?
Yes.
And here's a good amount of the clutch. So as we were talking, it's a frost technically to a frost, right? It was just with sable added to it. And we have a handful of different phenotypes here in frost. We have caramels that we would classify as a caramel, right, John?
Mm-hmm.
And then was there albino in this pairing?
Yeah, they were both heterozygous for albino as well.
Okay.
Yeah.
All right. So
that's where you're getting the red-eyed versions there as well, which I couldn't say for sure if that's a red-eyed version of the caramel or if it's a red-eyed version of the frost at this point in time. I'll know more about that. These animals, these are adults now, and I do have offspring from those, but I don't have any babies that would be in this same classification. They've been outcrossed again. So, yeah.
Okay. Let me see if we're trying to get Eslin audio fixed here. Give me a second, guys.
So just a quick question with this, if it's okay.
Mm-hmm.
So from this pairing, we would expect all of them to be het sable.
Mm-hmm.
And then you would expect to see really just two different phenotypes. You'd expect to see, somehow reason that gives us balloons. All right. I knew that one gives a thumbs up, but I haven't seen the balloons. So we've got all of them are het sable, and then there should be two phenotypes. They're either frost or albino frost, right? So
Correct.
really we could only see two different things, but it looks like almost four different things, at least three.
At least three. Yeah, at least three.
So with that being said, Eslin also sent me. So this is my pairing from last year where it's a small clutch, small sample size, but it was a triple het to triple het. Got Evans hypo. So I know at least the female produces Evans hypo. So this year I did a visual frost conda to this visual frost conda to the same female. This year I got frost, caramel albinos, normals, but no visual hypos out of two clutches. And there's the other clutch. So same thing, different variations of the single visuals that we're getting.
Interesting.
And then with Eslin, I think, let me get through here. Oh, he's in the beginning. Hopefully. So with Eslin, he sent us it was a super Arctic frost conda to a frost het albino het toffee. One of the first things that I asked him when I received this picture was, is this a conda caramel? And he says no, right? Because it's a frost to frost pairing. So there shouldn't be no single visual caramels, but definitely phenotype definitely looks totally different. And he said there was no, if I'm not wrong, there was an albino. Let me see if we can add him here.
Okay. No.
Eslin.
Yeah, can you hear us?
It says you.
Yep.
Yep, we can hear you now.
Like, finally, Jesus. That shaved
There
about 5 years off my life.
10 off of mine.
We got it.
10 off of hers.
Thank you for the technical help, Nikki.
Yeah. That's why the big bucks, bro.
That's right. That's right.
So this pairing right here was from a super Arctic frosted anaconda, which was the world's first, to a frosted het albino that were completely unrelated. So I've been listening to what you guys were saying, and I listened to what John was saying too. So I originally purchased frost, a 1.2 frost, which one of them ended up being a frosted conda, which was one of the first ones that clumpers ever produced. That's what I originated with. I never added simple caramel, and I never added simple hypo until later on. So I had 3 animals that were unrelated, and then I used that to start all of my outcrossing those animals, starting all my projects. So this pairing right here was the first official pairing that I ever did that I put frost on both sides, because I felt safe enough for me to be able to breed frost back to frost, since I originally started with a small sample. I got no normals. I got no caramels. Everything that you see there is frosted, Arctic frosted and Arctic frosted albino. So
yeah, so and that would make sense if the Arctic or if the frost is homozygous for caramel and homozygous for the hypo, then all babies should be homozygous for both. So that's kind of, that part's expected. But het albino and het toffee, those are different lines of albino that aren't compatible, right?
Correct.
So so those albino looking ones,
I might have mislabeled.
Yeah, those are Arctic albino frosted anacondas. The one thing that I did inherit that came deep within the frosted line, the one female that was anaconda throws that very nice reduced pattern and stripe, which is very prominent in my lineage.
Now I want to talk about something as well, because I know you hatched it, Eslyn, because I said something to you about it when you did, and it made me scratch my head. You know, I produced those blue-green frosts. You produced one in a clutch, and it was the oddball in the clutch, correct?
It was. That was from outcrossing anaconda triple het permafrost, which is Sable Evans Hypo Caramel, to the Arctic albino anaconda het permafrost that was from your line.
Yeah. Okay. So that makes sense. So you hatched one of those blue versions,
correct,
of the frost that came in. That's what I'm talking about, Ben. Yep. Where
and as a matter of fact, I don't cut you off, but as a matter of fact, Jamie also produced a clutch. I think yesterday, and he got a lot of those blue frost as well.
Yeah,
he were permafrost, and I told them, unfortunately, I don't mean to burst your bubble, but they're not permafrost, but there's some really nice frost.
Yeah, so that's what I'm wondering, if that phenotype of frost passes its genes differently than the typical gray style that Eslin is showing here.
Well, this is gray only because they're Arctic.
Right. No, I'm just using it as an example. Like, I know there's additional genes in there doing it, but we see frosts that are brown. We see them that are blue. The ones that I have always been unique until you hatched that one, Eslin. And I didn't know that one of the parents came from some of my offspring. So, or, from some of my genetic material, at least.
Correct.
So that makes sense. It's
remember that the frost combo is still relatively fresh, even though it's been around for
20 years,
15 years that it's been worked on. So, and remember too that there's some speculation going on with the Evans hypo as well. The Evans hypo, as it is, people thought that there were two types of hypos. There was Evans hypo and there was Dutch hypo. So the reason why that got discouraged was because the person that was supposedly commenting on the fact that they had discovered a second hypo ended up being allelic with the Evans hypo. So they bred an Evans hypo to what was suspiciously a new hypo, and they all came out hypo. So they said, well, there is no Dutch hypo anymore because they all proved to be the same gene. So that's kind of what people were speculating was going to happen with the Swiss and the Sable, remember? But it didn't happen. So it was the exact thing that happened with the Evans hypo and the Dutch hypo. But still to this day, there's still people calling Dutch hypo, and Evans hypo, Evans hypo. You go to Morph Market and there's people classifying Dutch hypo because it comes from Europe, or vice versa, Evans hypo because it comes from the States and all. So there's some, I don't know exactly the full details on the Evans hypo, Dutch hypo, but what I was told early on when I first started, because I always liked frost. It was something that drew me to frost because I like purple. I like that earth tones. I like that. So Clumpers told me the same thing, that when he was getting hypos, he would get a variation, like you were saying, John, in the beginning. He got a variation of them because when I first got mine, I told them, they kind of look a little different. I got a little bit of the gray ones. I got some that look more brown. I got some that look more like cleaner look, like they have a little bit more of a light background. And that was the same thing. It's like, oh, they vary so much. And as I started producing more, I started realizing that, okay, when I get a caramel, my caramels are usually really light. And then other people were getting darker caramels, kind of like the ones that you're getting, John. And then they would start selling them as they were frost. And I was like, look, that's not a frost. That's a caramel. Oh, but everybody else's caramels are light. Yeah, they're light, but yours is a caramel. Look at the tongue, look at the eye, and look at the belly. Those things were the deciding factor. So a lot of people, unfortunately, were selling caramels as if they were frost. And even some hypos end up getting the nice, you know, the nice line between the belly. Some hypos end up getting that as well, which is why I'm like, okay, something else is going on. Like we spoke before, John, about your hypothesis on how that goes. I'm not gonna sit here and say I read 150 books on genetics, because that's a lie. Everything that I've learned is through trial and error since I started eating and breeding, you know, different species. But as you know, whatever muscle memory you have when it comes to any other species, when you deal with hognose, you start from zero.
Yeah.
You start from scratch.
So John, your original triple hets, were they likely just one line or the other, or is it possible you had, if the two lines are actually genetically different, they could be compatible but still different mutations, and in some combinations they could act differently? That's definitely a possibility. Do you think yours were likely to have both Evans hypoline and the Dutch hypoline, or were they likely just one or the other?
I can't answer that. I don't know.
I don't think anybody will have.
Yeah, I couldn't answer that. Like, to be specific, you know, they originally came from John Michaels, and I want to say that he got his frost from Clumpers, and then the sable from Dan.
Yeah.
And that's when he made those hats, and then he sold his collection, and that's when we bought
correct
those four.
That's exactly what happened. And even the permafrost that were produced that other folks had purchased from the same group that John and Mitch have purchased theirs looked similar to the ones that they produced. They have a very unique look. They definitely do. They have a very unique look. And the even the oxides, which are the sable hypos that John and Mitch produce, are very unique.
Yeah, I think that's definitely a possibility that those two could act differently in certain combos. So if that's possible, you have both those lines in your original triple hets, that could be what's giving you some extra variation. That's possible, and something we are working on hog morphs right now to develop tests for them. So that's good to know. We'll keep an eye out for that. See if we can.
That's going to make it way easier to where we know, you know, because I mean, you know, I've looked at, you know, DNA breakdown before to show where this specific gene sits, you know, on these loci and things like that, and how it affects things. And that's why I said before, I'm no expert by any means, but I feel like this is like happening in not just like this, you know what I mean? But it's happening in like this, you know, there's a lot of things going on. And then you get variation across here where like maybe these two are the ones that really make a difference. That's why I made that thing where like this could be frost, this could be frost, and this could be frost, you know, because of the other genes that are there as well that overlap. And then when you breed them, like this set of the genes go over here to the offspring, and that's why it, you know, reacts the way it does or whatnot along the lines. But like I said, I don't know, you know, much of anything from that. So
okay, yeah. And JMG saying that the Dutch line is the same. They came from Richard Evans.
Yeah. No, that is correct. I've done a lot of research on that gene as well, and the Dutch. I don't think, you know, anything there unless they unlocked another mutant gene that could be following with that over there. But they are the exact same. Gene. I align with that.
Looking at your clutches earlier specifically, to me, it looks like there's another mutation going on. That's the easiest because your triple hets look like normals and you can produce all three. Then the next thing I would say that's giving you those extra phenotypes than you would expect would have to be another mutation that's floating around in those animals.
Yeah, it's possible. and it could just be a mutant type gene or something along those lines. Could it be a polygenic type gene then that's floating around in there as well? I mean, is that less likely? Yeah. Okay.
I haven't looked at as many hognose clutches as I have ball python and carpet python. That's the two that I've bred the most of. But I do see, like, when you look at ball python breeders, they don't really talk about polygenics. Pretty much everything they're working with are single, mutations that cause this trait. But when I look at, what you all post for sale and you're talking about, I can see there's, obvious, not only in hogs, but in corns and stuff like that. It's pretty obvious there's some polygenic things going on in boas and emeralds and green trees, lots of other species. So yeah, that definitely could be something too. If you are specifically choosing to take the ones that have that bluish look and that starts to increase, instead of seeing a couple each clutch, you start to see like half of them, then that would be more likely. If you're selecting for it and you're getting more of it, then that would be more likely to be a polygenic trait. But if it still kind of seems to, show up like a fourth of the time or half the time, and it stays that same way generation after generation, then it's more likely it's a single additional mutation that's causing it.
See, that's why I brought up the thing. I remember specifically when Eslin hatched that one, and he had that one unique frost that looked like mine in there. And I was like, boom. I was like, don't sell that thing, man. I was like, that's one of them weird blue ones like I get. And I get them all. They're all like that, Yeah. And so it just acts. It acts very, very interesting,
Yeah. So like when you're talking about Labrador retrievers, so you have black labs, yellow labs, chocolate labs. Mm-hmm. So that's actually an interaction from two different genes that are on different chromosomes. One that allows black color in or not, if I remember right. And then the other one that it's like a dilution factor that kind of makes the difference between the chocolate and the black. But yeah, that's an interaction of two genes that are in different places. So it definitely happens with color and pattern in other species too. So it could be that either, in one or the other, or maybe all of those triple hets you got, they could have had another gene, another mutation in another gene that also has an effect on whether you get that bluish look or not.
Yeah.
Yeah. And with the clutch that, as I had mentioned earlier from Jamie C. Hognose, same thing. I was talking to him yesterday about it, and some lineage came from John originally. I think there was some original male put to some of his females, and then back to a couple outcrosses back, but there's some lineage from John's and Mitch's frost stuff, and he's getting the more of the bluish tints. So it definitely looks like a line bred trait, maybe. And then with I'm trying to catch up now with all the technical difficulties, but with the with not being able to produce hypos out of visuals or heads to visual, what is what can be a reason for it, Ben?
So what I'm seeing in those pictures, and you all definitely feel free to tell me if I'm off. I very well could be, but if you're breeding a frost to a frost, you should see everything looks frost. You shouldn't see a difference. Correct. They should all be double homozygous, so there should not be a lot of variation in what you're seeing in that clutch. So that specific breeding, I would never expect to see just a caramel or just a hypo. And the fact that you get some that look a little bit more one way or the other, that's kind of weird. So, in that specific case, but like if you're talking about a frost to something that's double het or only het for one or the other and homozygous
like this
for the other.
On the screen now.
Yeah, so this is, when you say het frost, it's a double het then?
Correct, yeah, double het.
So okay, that's a predictable result then, except for the no single gene hypos, but that's not unheard of. You know what I mean? Like, I've bred, het sable to het sable got, 25 eggs in one sable, so I mean, and vice versa. I've bred, het for sunburst to a sunburst and got all sunbursts.
Yeah.
So I think there's that really weird, statistic there. But I think if you look over 1,000 animals and 1,000 eggs, you're going to be more of that, 50-50 or whatnot, after you get to all those clutches. But switch to the one of mine, the frost to frost. So right there. So so this is where it gets weird, and this is consistent. This is like every time with this breeding that I get those weird like caramel question mark, and that's where I go back to, like, is the blue ones just expressing that extra trait that we're talking about, and maybe that other one is either a different version or is not expressing that trait? I don't know. I am breeding. I have bred those animals this year. So, I mean, unfortunately, it's not. I just wanted to forward another project. So I did it, but I can, put them into a same classification to really understand what's going on more there. Like, breed that caramel question mark animal to a frost, one of my visual frosts, and see if it produces both variations at more of an equal amount than just like one or two popping up in a clutch of 16.
Yeah.
See what I'm saying?
Yeah. One thing that this kind of reminds me of, I bred some Hondurans. So with Hondurans, with their hypos, they get some that have what they're calling hypos, which also might be a kind of T positive, because some of them have very red eyes, but some don't. Some have like black eyes. It's still a hypo, but it has black eyes. Whereas some, they'll call them extremes or ultra hypos, and those will have the red eyes. So I'm wondering, and that seems to be, I would say, from the clutches I've seen, and I've seen a lot more of that than I have hogs, that seems to be kind of a polygenic thing. Like, you can kind of increase how many of those you have, and then some people that have bred specifically for the extremes or the ultras, they'll get a lot more of those, a higher percentage per clutch. But I don't know that you can essentially get to where you make all of that, which would be what you would expect if it's just one mutation. You could eventually get it, just like a frost to a frost should give you all frosts. These hypos, it doesn't seem like you get, extreme hypo to extreme hypo, you get all extreme hypos. But yeah, I'm wondering with this, is it possible that you're seeing albino, like that caramel question mark versus the albino caramel question mark? Is that possible? Those are albinos. Do you see that kind of variation in just albinos, where some of them come out with a darker look?
Yeah, but that caramel one doesn't have red eyes.
Right. And that's what happens with these hypos and Hondurans. Like, they both look like hypos, but the ones that have red eyes do look a little nicer.
Yeah.
But like, if you set them side by side and look at their eyes, like, they're totally different.
Yeah.
But it is the same, like, it's the same hypo mutation that's the base morph that you're seeing there. But there is some variation there that seems to be polygenic. When you breed albino hogs, do you see some of that also? Do you get some red eyes and some black eyes?
No.
Yeah. So
the only black eye thing is the Diablo, right? But that's not an albino. It pops up in hypo?
Yeah, no. and I don't think he's talking like pure black eye.
Yeah.
I think he was just thinking that
the darker, normal looking eyes.
The black pigment is not removed.
From the eye. The Diablo only influences the iris. It makes it a solid iris. Doesn't influence the color. The color is influenced by the actual gene, the recessive gene or whatever. And in that case, albinos. But I could tell that the one that's labeled albino frost or albino caramel, you can see that one is an albino frost. And then the one up there that's also there, to me that's albino frost. That caramel right there is definitely a light caramel. So I can see that being caramel and not frost.
So you think in this pairing, even though both parents had homozygous for both caramel and hypo, that somehow this one didn't get homozygous for the
hypo gene?
The hypo.
Mm-hmm. Yeah.
Yeah, and that's the same. So that is the same experience that Mikkel Klumpers is getting over there when he breeds Frost to Frost.
I believe AML did too. She posted
Yes.
one time as well.
Yep.
Mm-hmm.
So could this be so going backwards, like I said before, I call it, I was like, are these allelic? Probably not. You know what I mean? But is there something that could be like could there be like some type of gene linkage going on to where it is affecting a phenotype there in some way, shape, or form, and just the way they're being expressed to where that caramel could actually be a double visual, but since they are being expressed that way because the genes are linked in some way, shape, or form, because it's weird, to me that we're getting these results. They came from the same lineage of animals. They came from the original first hypos. You just magically get these. Because, that was like the late 90s. And by 2005, they had the double visual frosts already being produced. So it's odd to me that it happened so fast. It wasn't like 20 years later, you got this other gene and you put them together. And then all of a sudden they seem to be linked in some way, shape, or form. But I just don't know how. Like I said before, it's like this, and how they're linked on that side, is how they're getting passed, either that way from the male or this way from the female or whatnot, and being, influencing the next generation. I don't know.
John, you remember when we spoke about how adding your Arctic albino anaconda triple het permafrost to my anacondas that are triple het permafrost. In my original pairing, I never produced a caramel. I only got singles and frost. I didn't get hypos, and I did not get any caramels.
Right.
When I used your male, I ended up getting a caramel, and that was it. I got sables and I got frost. I never got hypos.
Yeah, no hypos. I'm not hatching any hypos either. None.
Exactly.
Except from the original parents. So the ones that I have that I've gotten from those original parents, I've used those to incorporate and go, a million different directions with them. Outcross. Go 3 generations, bring them back together. And that's where I'm still seeing it, to where it's almost like they're not passing the hypo gene as the single gene, only as the frost gene.
Only as frost.
The frost or caramel.
I honestly say that
only caramels the only hypos I hatch are from my ghost projects. That's the only hypos that I ever hatch, never from permafrost.
I don't hatch any caramels from any of my ghost projects unless I added it.
Mm-hmm. Yeah.
So if I'm going for Casper, I'll get it. But if I'm not going for Casper, where it's just ghost, I don't have no caramel pop up or the influence of caramel with the fine line in the belly or anything like that. It's just classic hypo bellies and classic ghost and Azantics, and that's it.
Yeah. As a break down the ghost and the Casper for Ben, because I know he's not familiar with all the combo nicknames.
So Casper is Azantic, Evans hypo, and caramel. That's the 3 genes. It's one of the ones that were originally made because people were breeding frost into Azantics, and then if you did it that way, you would get caramels. If you did Evans hypo to Azantic, you would only get ghost. Very little caramels. You wouldn't get caramels unless you started with frost, and then that was the difference. So caramel is rare when you start with hypo. Hypo is rare when you start with frost. And then you will get caramels in the mix if you only do the triple hets, and the triple hets is where you'll normally get the variety. But if you start with a frost on one side and then you hit it to a double het, you're mainly going to get frost out of it. You'll get some caramels, but it will be far and few in between. Hypos as well, few and far in between. I'm not going to say you don't get them, but they're rare. You'll hit, let's say, out of 10 babies, if it's a clutch where you're going to hit the double visuals, you're going to hit almost 7 out of 10. and you'll get very little out of them. And then vice versa. If it's going to be one of those where you don't hit a lot on, you're going to only get 1 or 2, and then the rest are just going to be normals. And it's the same thing with the albino. When you add albino into it, a lot of the ultra males, it's same thing. Hypo and albino is kind of hard to hit when you have an albino frost project. I don't know how have you hit on albinos, John? On your albino?
No, I mean, I haven't hit any of that stuff.
I think I produced probably close to 400, 500 eggs, and I think I've proven maybe 4 hypo albinos. And ultra males I get a lot, which is caramel albino. I'll get a few of those, but I haven't really seen many albinos. So
Miko Klumpers told me he in 2008 he was sending in 300 to 500 albinos into the country, and almost all of them were visual caramel as well. He said nobody wanted to buy caramels, but they were the double visuals and people like those. So,
the double visuals are nice. The ultra males are really nice. They're very nice.
So I mean, going back to that, it's just interesting how they are passing the genes, themselves. So, and how it's so tough to get some of these going backwards. I spoke with Jeff. He said it was about a year ago. I remember, this in particular. It may not even been a year ago when we talked about it, because I was like, hey, man, I'm getting these weird results. And I showed him pictures, of my frost to frost breedings and me getting the caramels. And he's like, yeah, it's cool. It's neat seeing those weird oddballs. And I was like, yeah, it is. And, and we briefly went on, a conversation about it. And he was like, and I refreshed about this today, but I remember the specific conversation about these breedings. He was doing het frost to het frost pairings, and out of like 130 eggs, there were no variation. It was just frosts. I mean, now there were normals, the normal possets and stuff, but there wasn't the other sides. It was just frosts that were popping through. So
he wouldn't get caramels, get hypos.
Yeah, that's what I was just going to ask. So he's breeding double het to double het. Mm-hmm. And only getting, man, I'm getting all kinds of weird things. I'm unlocking all the codes. I got to stop talking with my hands, I guess. So double het to double het, he's only getting frost almost never or never caramel or hypo.
Yeah, almost never. I want to say there was like a very few, like 1 to 5 or 1 to 3 or something. Maybe if he's still listening, maybe he'd chime in, or Crystal, he's yelling in the background, maybe you could be like, yeah, he said 3, but it was all the double visuals, that was being produced, and not the other side. So
that kind of data, if anyone has, like, if you have any data from when you're doing triple het to triple het, or like that data you just talked about where he's doing double het to double het, I would love to get that data, especially if you have an N of 130. Then I could probably give you a much better answer to see what's going on.
Yeah, and I mean, I think that's, it's similar, to what, Klumpers was getting with his frost to frost. He's like, yeah, I would get frost, but then I'd also get caramels, that popped up. So it's similar to mine. Jeff's getting these weird results. I'm getting fucking real weird results out of, my lines since the triple het breedings, and how they're being passed along, and then how they're visually, representing themselves as well. So this is one of the funnest combos I think that I've ever worked with. In hognose snakes.
Surprises.
It's the surprises, and not being able to predict, what's really going to come from it and things is incredible. And I've got all these weird double visual animals from these. I think I may have a super Arctic permafrost, but maybe it's not even that. Maybe it's some other genes that are playing around with each other. I've got super Arctic Conda caramel. Alvaro, can you put that one up on the screen?
Yeah.
It's a weird looking animal. I mean, it followed the same inheritance that Jeff made the super Arctic toffee bellies a while ago. So they're both similar types of albino. I'm not saying toffee and caramel is the same, but they're both kind of like a T positive type albino, and they make, when you add super Arctic to it, the genes all act, together the same way, and they make these purplish animals instead of like the typical T positive type animals. And same thing happens with toffee belly, like I said, mai tais, everything. They make these purplish animals, but it's real interesting how it does that. And I want to say, I don't know, I think hypo looks a little different. I think it's more of a red look on the super Arctic hypo side.
It is.
But, yeah. So this caramel definitely throws these purple hues as well.
Yeah. So, and talk about heads to heads. And last year I did do a head to head, small sample, but I did get a hypo. And yeah, I think it was only 5 animals. We had saw the picture earlier. Now that female did pair again this year with a visual, all frost, caramel albinos, and normals, and albinos. So they were both het. The male was actually het for albino. So again, interesting that the prior year, right? I got hypo, but not this year with the same female, different males. The male haven't been able to prove out if he does actually carry the caramel gene yet. So that'll be maybe a future down the line next year to see if I can prove that out. But the male came from Eslin.
I got pushed back on you on that one, Alvaro. Yeah. You did make caramels. They just
no hypos
or hypos. You did make hypos. They were just the double visual.
The visual, yeah.
You know what I mean? Yeah. So it's what we are saying, it is a double visual of. So
yeah,
it's an interesting way of inheritance. So
no.
So even with my lavender frost stuff, it's the same thing. It's hard to get purple haze. How many purple haze have you seen in a long time? John, you remember they used to be around.
Oh yeah.
It disappeared. And purple haze is the lavender Evans hypo.
Yeah.
Then lavender caramels have popped up. Probably, I don't know how long now, a couple of years, and they're super nice. They're really, really nice. It's the same thing. It's difficult to hatch. They're difficult to hatch from head to head. It's almost impossible. I have maybe 75, 100 eggs, and I've only hit one visual. I had a bunch of lavenders, a bunch of caramels, a bunch of frost, but to get the triple was very difficult, very difficult. And I don't like to breed too many recessives on too many double visuals with double visuals and all of that. I take it the long route because I'd rather animals be healthier than hit a big load of double heads or double visuals that are worth nothing because they're not gonna, not healthy or anything like that. I wouldn't do that, but it's the way to go if you want to produce so many of them, because you have to. In order for the people that are producing numbers like that, if they're not sitting on 500-600 eggs to try to hit 20 of them, then they're gonna have to be doing it that way. And unfortunately, that's what I'm assuming is happening with those people. But the caramel gene is weird too, because did you ever breed caramel to caramel, John?
I mean, kind of. There's always other genes that are involved in there as well, but it's I'm getting similar results. I mean, it's acting. Caramel's acting more dominant in my collection than the hypo gene side of things. So it's
and the caramel too. Haven't you noticed there's certain caramels that don't get the reduced head pattern?
Yeah, some of them don't.
And some of them won't get the nice, faint line on the belly either.
I would say most of mine do. There may be one or two off that look a little bit different, but
yeah, I noticed that too. There's some that show no belly pattern whatsoever, and then there's some that have a lot of belly pattern.
Yeah,
and some of them have reduced. They're supposed to have reduced heads, like very reduced head pattern, and some of them don't. Even in the very beginning, the really nice ones will have no pattern all the way to like the first quarter of their body.
Yeah,
everybody think they were conda, but they weren't conda. They were normals. It's just such a reduced pattern, and then that you don't see it as often anymore. So
Ben, with the information that we've given you, minus actual data from, you know, lots more clutches. I mean, I can supply you with some this year that I do, the actual different phenotypes and things that I pull. But what do you think's going on? Do you think it is like some type of gene linkage that's going on, or is there something a little bit different? You know,
So-
like I said before, these are all theories. I said allelic just because I wanted to go back. I think the only allelic genes that I've ever known in snakes are hypo and motley and boas. I think that's the only ones that I've actually ever known to be truly allelic. So I was just using that as I don't know what the heck I'm saying. But they are definitely linked in some way, shape, or form. So that's the analogy that I was using there. So
yeah. So that is something that does happen. It is called gene linkage.
Mm-hmm.
So it's like two different genes, but they're on the same chromosome. And if you remember, like high school biology, where you have a crossover event that happens with two homologous chromosomes. So it's chromosome 7 that, you know, albino is on. And if you have a chromosome that the animal got from mom, the one they got from dad, and those get close to each other, they can have a crossover event. So if like, the purple haze was lavender and what else? Hypo?
Evans hypo.
So if those two are on the same chromosome, but different genes, but they're fairly close to each other, and it came from breeding a lavender to a Evans hypo, then you would get offspring that all have a chromosome from the lavender parent that is that one chromosome. It has the code for lavender and it's negative for hypo. And then the one from the other parent is negative for lavender, but positive for hypo. And then when they breed, if they're close to each other, they're not going to cross over in between. So the babies are only going to get one or the other. And so that's what would make it really hard to get from double hets to get visuals because of that linkage. Whereas once you do make a visual one, then that means that crossover event has occurred. And so you have both hypo and lavender on the same chromosome. So then their offspring of that animal is going to get both or neither. And so it will breed very differently than if you're breeding double het to double het.
So that is awesome. That is
a lot of
wonderful stuff right there.
Yeah. And
so
the biggest example
to get there is the difficult part, and then to go backwards is even harder.
It just makes
it can be hard, especially if you have common ancestry that's going on inside of that gene pool.
You know, so like from, you know, like if I'm a breeding genetics person, you know, consulting with somebody, you know, if you don't know that linkage is a possibility, and especially like what you were saying, Eslin, that you want to try to keep things as pure as you can. So you're working from het to het kind of stuff, or, you know, making double hets and breeding those. Yeah, if that's all you ever do, you're always going to be fighting that linkage that's going to make it difficult to make homozygous animals. But if you take those double hets and breed them to each other, do enough of them, and you do get that crossover event to occur, then if you understand what's going on, then you can plan your breeding to use that animal, you know, has both of those mutations on the same chromosome. The way you do your pairings will change so you can optimize more homozygous or double homozygous offspring. So it really, you have to kind of know that and how it works up front to be able to optimize your output. But yeah, with that purple haze that you're explaining, that sounds exactly like those two are genes that are on the same chromosome that are close to each other. In ball pythons, the most popular one that has this going on is banana.
Mm-hmm.
Yeah.
So they got bananas in, and all they could do is make female bananas. They're like, oh, we're never going to be able to make a male. But then eventually a male popped up. And when they bred that one, all it did was make males. And then eventually they figured out where banana is and the sex determining region, they're on the same chromosome and they're close enough that 95% of the time they pass together. So if you have a male banana that came from a male, that means that mutation is on the Y chromosome, and every baby that's going to get that, they'll travel together. So all the male offspring will be bananas. But 5% of the time, there's a crossover in between those two, and that mutation moves to the X chromosome. And once that happens, then you get a female banana. And then if you have a male banana from a female, that mutation is on the X chromosome. And so that male is a male banana, just like before, but that mutation came from an X. And so all his female offspring are going to get that. So that's the same kind of thing that you're likely fighting, at least with the lavender haze. And it could be something that's going on. If I see the numbers or the frost stuff, that might be, oh yeah, that's what's going on there too. Yeah. I would just have to see those numbers, especially your het-to-het breedings. That would give me an idea of if you have another mutation that's also causing that bluish look, or if it's some kind of linkage thing going on.
Yeah.
Okay. Yeah. And John, right? We were talking with John earlier this morning, and I brought up the banana situation too.
Mm-hmm.
Yeah. And so, guys, right, Ben, if you're working on getting hognose genetic testing, right, and if somebody has these results like Eslin, John, if they have the records, whoever's breeding, especially heads to heads, you said for frost, how can they get this information to you? What's the best way to do it?
So the best way, I tried to post a link earlier, but it wouldn't let me. I don't know if it just doesn't like links in the comments, but if you just go to the Rare Genetics Inc. Website, we have a big button. I think it's in the top right, at least the computer version, but even on your phone, it'll pop up pretty easy to see. It's a big yellow, it says, help us design new tests or something like that.
Mm-hmm.
So if you click that help us button, then it will give you a PO box that you can send sheds to. If you want to just like send me data, if you message us through either Instagram or Facebook, Rare Genetics Inc., that'll get to me. Yeah, there you go. Somebody, yeah, you got it to post. Good job. Perfect. Yeah. So go to that link. It'll always have the most up to date. Like if we have to change addresses or whatever. That's why I don't like giving the specific address, because in 6 months or a year it might change, but we'll always have the address to send sheds to help design new tests. But yeah, if you have data that you want to send from pairings that you've done, just reach out to me. Instagram, Facebook, those are probably the easiest. And I would love to crunch data, especially if you've got, I know some hog clutches are pretty big. So even if you had 3 or 4 clutches, if that's, 80 or 100 animals or whatever, that could tell us quite a bit.
Yeah. And then as we were talking earlier too, another example too, not to go too much, JC Hog just sent me these photos, and this pairing was I'll tell you guys right now, was a frost conda, so a double visual, het albino to a sable het frost. He said it 15 babies, 15 hatchlings in the clutch, either frost or normals. So saying, they're right. We can maybe just hit great odds, right? We hope, but like you said, maybe there is some linkage where the ancestry passed on how this is going down. Now, with that being said, if you have an animal that produces, let's say a female, like my female, she produced hypos and produced visual frost, but no caramels yet. With that female, do you think she could produce caramels, single visual caramels?
So what was, say the pairing again? Is it frost to frost?
No. So my pairing was frost conda to het frost. This year, that was a pairing. I got all the visuals, but no single visuals, and no hypos in any combo, other than in the actual frost. Last year I did het to het and got actual hypo single visual.
Yeah. I mean, obviously she should. If there is some kind of weird linkage or another gene affecting it, maybe that will make it hard to see. But yeah, I mean, she certainly should be able to.
I gotta get a single.
I follow what you're putting down.
Yeah,
that goes back to my diagram that I wrote. is it even possible for those animals to make hypos? You know, because of the linkage that's going on, or can they only make frosts and caramels?
Well,
So yeah, you know, that's.
I got the perfect male to test that because I got a caramel anaconda and he lives down the street from me. So how about next year, for the sake of science, you breed your anaconda triple head to my caramel that's not head for anything.
Yeah.
That
And then we can see the outcome.
Yeah.
Mm-hmm.
That may be the way for you to unlock. You may not produce any caramels, but those babies may be able to produce caramels after that.
Mm-hmm.
Because I don't know. I don't know. Like I said, you know, I'm just.
we're all some kind of mad scientists, right?
Give me clutch data.
Yeah.
This is the struggle with the frosted stuff, because you're like, okay, next year I'm going to try this to see if I get something different. And you do get something different, but then it throws you back off what you originally thought. And then you're like, okay, I gotta, you know, regroup, because I still haven't produced a permafrost. I produced sable, I produced frost, I produced one caramel, and I've used the same female, so she can produce what we would know. She can produce permafrost, but she hasn't given me any triple visuals. And I've used 2 different males on her. This year, I actually bred her to a permafrost male. And I don't think she ovulated on me, so I don't know. I might strike out this year and then have to, you know, regroup next year and see what happens when I do produce or breed her to the permafrost male.
So Ben, let me ask you, because you know a lot more. I'm not sure if you're pretty familiar with the pricing on ball python and stuff like that. Like, are people seeking more banana female makers or male makers? Is there a preference in the ball python world?
It's definitely changed a ton over time. Early on, people wanted the female makers. They wanted to be the only one that had a male, and they can produce a bunch, either males or females, but just sell the females so that they could, you know, make a whole bunch before the prices all dropped. But then for a while, you would want female makers so that your cool banana combos, you know, would all be females you could hold back and breed or whatever. But now I would imagine that it's just kind of like
whatever's coming up,
or spider or anything. Like probably a female is worth a little more than a male, but it's not as big of a deal anymore.
Okay, yeah, because you know, now thinking like how you were saying, now if we start figuring out how these genes are being passed down and how they're reproducing, maybe eventually we're going to have to start, whatever outcomes we want, we're going to have to start stacking our pairings and, okay, this animal produced these X, you know, caramels or frosts or hypos. I'm going to keep these many to be able to produce this X, Y, and Z, right?
Yeah. I would say one thing, maybe, I know some of this is kind of complicated to think about in just 1 hour. I've taken many like multiple month classes about this stuff. So, but like a rule of thumb, I think that would be helpful to you in this kind of a situation is to think differently about an animal that's double het that came from homozygous to homozygous. That double het is going to breed differently than a double het that's made from a double homozygous to a normal, or it could be homozygous for one, het for the other, or even double het is just coming from one side and it makes a double het. If there's any linkage going on, those two are going to breed completely different from each other, because if you get both hets from one of the parents, then that means it's likely on the same chromosome, and it's going to breed differently than if you got it from homozygous to homozygous, then those two hets are going to be on different chromosomes. And if there's any linkage going on, the babies are just going to get one or the other most of the time. So that's going to breed totally different. And if that linkage is 99%, you're like almost never going to make a double het from a homozygous to homozygous double het. But that 1% of the time you get it from a double het or a double homozygous, you know, any of those you get, obviously they're going to have both of those mutations on the same chromosome, and their babies 99% of the time are going to get either both or neither. And so it'll be a very different outcome. So that might be helpful. Think about your breeders different.
That makes sense. Maybe why I get so many frost when I breed frost to frost rather than getting caramels, hypos, and frost, or caramels and frost. Because I started frost. I started.
Ben, exactly what you said is what I tried to draw a picture of, because I didn't know how to put it in words.
Yeah. We're gonna share John's artistic talents.
I tried to draw it on a computer, and I was like, "Yeah, this sucks." Look, and that's literally how I was trying to explain that. Yeah, exactly how you did it. So
a visual explanation of this. I wish you had control of the what's it called, the pointer, Ben. But can you run down through this, like every from top to bottom, how what John drew and what we can visually see here?
So in my mind, I picture it a certain way. It might be difficult for me to fit it to this picture, but I think, so John, correct me or kind of help me explain this, but like that first picture, that kind of to me is like, homozygous to a homozygous. You're going to make double hets where the hets are going to be on different chromosomes.
Correct.
So it's only going to pass to one. The offspring are only going to get one or the other.
Yes.
They're almost never going to get both.
So, but like visual. Sorry, Ben. So visual caramel to visual hypo. Okay.
Yeah. So if you breed visual caramel to visual hypo, those babies are going to have one mutation on the chromosome from mom and a different mutation on the chromosome from dad, and they'll all have that. And if there's linkage, they're going to only pass those chromosomes to their offspring. So they only have one mutation or the other going to all of their offspring.
And that's where that's what's going on the right side of the screen versus the left side. Exactly.
Yeah.
Exactly how you explain that. I just didn't know how to, like, I was telling Alvaro, and I was like, man, I need to draw a picture to show you what I'm trying to say here, because that's exactly what I was trying to say with this picture.
Yeah. So then the other case, if you have a double het male bred to a normal and you happen to get a double het, which obviously without genetic testing would be hard to know until you start breeding them, but a double het from that animal would be rare. But when it does occur, that's because a crossover event happened. And so you have both mutations on the same chromosome. So it can either pass the one that has both caramel and hypo, or it can pass the one that has neither. So it's a different way to breed. That animal is not, even though it's a double het, just like the ones we just talked about, the way it breeds will be completely backwards from the other one. The first example we gave, every baby is going to get one or the other. Second example, every baby is going to get both or neither the majority of the time. So that very well could be what's going on. And like I said, with the purple haze, the way you explained it fit that perfectly. With the frost, I think there's enough other things going on that didn't click with me at first, but I would still love to see some clutch data, but that definitely could be what's going on there too.
Okay. All right. So we need to get back to the building blocks of this, right? Of the hypos and the caramel, to get back to the frost, to really be able to follow the whole linkage and see how it's going. Are you able to? I mean, you're able to figure that out just with shed testing when you're able to do it, when you have the availability?
Yeah. So what we could do, first of all, what I would love to do if I had a test for caramel and for hypo and for lavender for that matter, I would love to be able to get your breeders, especially ones where you see two different outcomes, ones where you see the weird, bluish ones popping up and ones where you don't, or ones where you do get purple hazes a fair amount of the time and ones where you almost never do. I'd like to test those parents, and then I'd be able to tell you, okay, yeah, I can see, this or that, I would be able to give you a concrete answer instead of having to, like the example I gave earlier, if you bred a double het to a normal and get a double het from that, you wouldn't know that unless you can test. So So that would help to find when, okay, now we've got that crossover event has occurred. So then from then on, you could breed knowing that animal is going to give both or neither to its offspring.
Gotcha. Okay. Yeah, because to be able to start from the, like I was saying, start from the beginning, that'll be at least 3-4 generations to be able to really follow everything down, right? Maybe 2. What do you guys think, John Eslin?
Yeah, I mean, the longer you can go, the better. I mean, it tells more of a story.
Mm-hmm.
You know how I do things. I reverse engineer freaking everything. So it's something that, I'm going to be doing this coming year with some of my permafrost stuff that I have here. So yeah, probably 3 generations. I think that'd be good,
And I think that's why a lot of, the well-established hognose breeders have had maybe a hard time pinpointing it, because a lot of people like John and Eslin did grab the original stuff and then start outcrossing everything, right? So it's hard to really
pinpoint. That's what I would do too.
Yeah.
But I mean, even this breeding year, like if you can collect, especially if you have like double het to double het or triple het to triple het kinds of breedings, that would help me out. And then also if I know what the parents were that produced those. So like the one John was saying at the beginning, where you have a double homozygous to another homozygous and then made triple hets from that. If I know that's how those triple hets were made, and then this is what their offspring look like. And then especially if I know, it sounds like you have some data for the generation after that also, those 3 generations, if I have that data, how the different phenotypes shook out, that would be very, very helpful.
I actually have some that will be hatching here in the next 3 to 5 days that are the 3rd season of that same one that came from. This will be the 4th generation. So I keep meticulous records. I have Excel documents that I could send you to show you exactly what came from each one of those breedings, and then the offspring of those, and then the offspring of those. So I could get those to you. That way, then like I said, this will be, multiple years of these same ones that I get the same consistent results over and over. So I'll send those over to you.
Yeah, that would be awesome.
Hey, John, do you notice a dominant pattern amongst not just the color, but the pattern on the frost that you get? Do you normally see a consistent pattern?
Yeah, I do. It is that very
is it twin spot, like the perfect twin spot?
Yeah, I wouldn't say it's perfect twin spot, but it is like a very spotty pattern on those bluish steel blue frosts that I get. Like, they're consistent as heck. Now I do get a little variation of the blues, but that's it. I think that's just typical variation that's happening there. But they are all that steel look.
Yeah. You're talking about like this Eslin here?
Yeah.
Yeah, where the pattern's not on the actual dorsal, but
like the typical frost pattern. No, 100%. Yeah, no, it is a pattern anomaly as well. I mean, you can see it in some of mine for sure.
Yeah, it influences the pattern a lot. I noticed certain lines when they're outcrossed, you could see where it gets watered down, but some of the original stuff, it's like that. The pattern on the back is very, very unique, and you could tell where it came from. At least for me, I can tell, especially with mine. When you look at my clutches, you could see the common, like when I bred it into Anaconda, I would get the same twin spot effect, but it would be dragged out with the Anaconda gene, and then it would just be like a very nice clean. Everybody thinks they're super condas, but they're not. They're all condas.
Yeah,
like that pattern was conda. There's no super conda in that Arctic clutch. There's none whatsoever. It's all clean. And then my condas look like that. I could show you 10 adults right now, and they're all pretty much the same. You would think they're super condas. Gabriel's looking at them. I don't know why you calling this a conda. I go, because I seen it hatch. I saw the spot there. I know what I'm talking about. I don't believe it. And it's funny because you see it, and then you could. That's the one thing I could predict from the frost. I could predict the pattern. And with the cameos, like I probably hatched 150 frost caramels, probably around 10 caramels only, not that many caramels. So that's a big difference. It's a huge difference. But then again, I also think that what Ben was saying made a lot of sense with the way that I didn't start from double heads. I started with frost. So maybe because I started with frost, I get more frost in mine rather than getting the caramels and the hypos. So if you start with when we start to outcross, I don't outcross with hypo to a caramel. I was outcrossing with a frost already, or with an Arctic frost, or with a super Arctic frost. Like my most exciting rack is all brown snakes. Because they're all outcross animals. Like I'm more here, like, yeah, you know what this is? This is heifer fighting. And people looking, it's just a brown snake. And like, yeah, but you don't know what to produce right there.
It's got the magic, though.
Yeah. But it's the same thing. I started with frost, and I always try to make double heads or triple heads with visual animals already, because I get the best one from this group, and then I breed it to the best one from that group that are not related to make the best of both worlds collide. And then the babies, I raise those females, and then I do the same thing again with a different line. I go, okay, I got this line. I'm gonna make outcrossed male for those females, and vice versa, and then bring them together. But what I did notice is that no matter how much outcrossing I did, the pattern was very consistent. That pattern was very consistent with mine. And I noticed that there's a lot of frost that, even though they're condas, they'll still have belly pattern. Mine lose all the belly pattern. Very rarely is there any flakes, any freckles of pattern on the belly.
Gotcha. Cool. And Ben, how much do you think, with Eslin talking about different, where we see maybe John and Eslin, they have a lot of polygenics involved in it as well.
This is sorry guys, this is my sidekick right here.
Would that affect people tracking the outcomes on the polygenics as well? I mean, not just the poly, but the frost or the outcomes of frost when you added a lot of different polygenics into it?
Yeah, as long as you're clear how you communicate it to me. So like if you also have some like extreme reds or like something else going on, as long as I understand, how you're characterizing, you're labeling these specific samples, I can either cut out any polygenic information and just focus on the others, or if we want to try to find some correlations with those polygenics, that's something. Once you have enough sheds, obviously we're just starting out with doing morph testing in hogs. 5 or 10 years from now, we may have sequenced so many that we could start to say, okay, for the extreme reds, here's 3 or 5 markers that increase your probability. So then you could, do a test, say, oh, this is positive for 4 out of the 5 markers for extreme red, or whatever polygenic thing is going on. But yeah, as long as you're clear when you send the sheds in. So the things we really like to see is some kind of unique name. So whether it's a name or a number, so that's your sample identifier. Then male or female, because that does help with some weird things like banana we were talking about earlier. Let us know what known morphs it has, and then any possibles. And then I would say, yeah, if there's any polygenic stuff, give me that information too. And then also, if you have any lineage information, hey, I got this from John, or I got this from Alvaro, or however, or this is from a line I've produced 5 generations. Like, just that little bit of information does help when we start to see something weird. If we see, oh, those all came from this person or that person, then that helps us figure things out faster. So all of that's really good information. You can't really give me too much information. I love all that.
Okay, cool. So, we're not going to drag it out too much, because I think we've come to a conclusion what is going on. We have a theory, right, guys? And I want to thank everybody that showed up tonight to listen. All 3, of you guys that came out and shared your knowledge. Ben, for sitting here and hearing us ramble through all this pairings, all that stuff, especially not knowing especially not knowing the names of the genetics, but right, the theory, right? And again, having you with actual, genetic brain here has made cleared up, I think, a lot for John, myself, and Eslin. I think for all the hognose breeders that are out there and people that are looking to breed the specific morph, right? With that, I had a couple questions for Ben. Any, I'm not putting you on the hot seat, but any timeline for hognose genetic testing yet?
So for anyone that doesn't know, we do have a sex test. So that helps some people. That's something we've been doing since 2017. It works very well on hognoses. Well, Westerns and Easterns. Tricolored hognoses is a different story. They're kind of a problem, but we do have a sex determination test if you don't want a popper probe. But the morph tests, we are right now, Kayla, that's on our weekly show with me, she loves hogs. She just hatched out her first clutch this year. Yeah, she in talking back and forth with me, she can tell I'm thinking about hogs a lot more than I have in the past. We have stuff starting up. So, some of the projects we started like 3 years ago, we still haven't finished. So I never know how long something's going to take. But the fact that we have so much experience with ball pythons, I think that the hogs are going to be pretty fast. So definitely in 2025, we'll have some tests unless something massively bad happens. So 2025 for sure. In the next 3 months, I think there's a chance.
Okay.
Yeah, by the end of the year, we should have some.
That's pretty cool to hear. We did have a couple questions in the chat. Does it matter, or do you guys prefer if it's sheds from visual, like from homozygous animals, or from het animals?
So if we have a choice, we'll always take homozygous because that sample has twice as much information for whatever it is we're looking for. So like if we're making a sable test, if you give us the homozygous sable sample, that has twice as much information, as that mutation twice versus a het. But the hets still help. The thing that is really bad is if you send us something and you say that it's a het, but it's actually not, then that can make our bioinformatics, so the software side of it, we'll take a whole bunch of sables. We'll take a whole bunch that we know don't have sable in them at all, or at least we can be as sure as possible. And then we sequence them, it's billions and billions of base pairs all get sequenced. And then we have the software go through, and it takes several days to do. It goes through and says, okay, here are mutations in the sables that are absent in the other group. And so if some of those are wrong, like if it was sent in as homozygous for sable, but it actually wasn't, or if it was sent in as a het, but it's actually not, then that can slow that process down. So if you're sure it's a het, as sure as you can be, send it in, tell us it's a het, that helps. But if you have a choice, a homozygous is better. And I saw a question, whether we would want both the parents and the offspring. That's definitely great. What we don't need is, like, if you have a clutch of 30, we don't need all 30 from that clutch, because, we'd have the mom and the dad, and then, 3, maybe 5 of the offspring still helps, but we don't really need, 30 from one clutch. That doesn't help too much unless they're all different combos. Then, if you have like 6 or 7 different combos in there, you could give us a couple for each of that combo. That still would help. But yeah, that definitely lots of sheds that helps. So everything's faster if we have high quality sheds with good information attached to them that's correct. Then these things will happen real quick.
Yeah. And one of the things that I've been doing, the easiest way to collect sheds, because sometimes we're super busy feeding, watering, stuff like that. The biggest thing, you don't want the shed if it's wet, right? Or you don't want it to be sitting in water. Try to dry it as quick as possible. But what I've seen a lot of the ball python breeders do is they'll grab it, hang it on the edge of the tub, close the tub, and let it dry, right?
Yep.
And then bag it later on. And so I've been doing that as well. It's clean. If I find something, hang it on the side, close it up, and then later on the next day when it's dry, I'll bag it up and collect it and send it over to you guys.
And we only need something like the size of a quarter, or if it's a small baby, or if it's a bad shed with many pieces, just pieces that would cover the top of a quarter. that's plenty. We don't need, whole sheds from adult hogs. I find that people that send in whole sheds, especially if it's from an adult, they're more likely to have problems because some part of that shed somewhere maybe wasn't completely dry, and then they put it in a Ziploc and the whole thing goes bad. So it's really best to just pick a piece that's about the size of a quarter, or a couple pieces that would be enough to cover the size of a quarter if it's a small individual, that are the cleanest and the most dry. And then, like Alvaro was saying, let them dry completely 100% out before you put them in a Ziploc. And then that's the perfect sample.
Yeah. And one other thing too, I've heard you mentioned relatedness testing, right? With John and Eslin, do you guys think that would be something beneficial in the future to see how closely related a hognose pairing is?
Yeah, definitely.
Yeah, no, I think that'd be good information. Me personally, I'm at this spot right now where I hate anything beyond an F1 breeding, like myself, like sibling to sibling. I avoid it at all costs. I try to bring in at least 4 lines for a project to be able to keep them clean and just stable. But knowing that, I think would be good. That way, my rule of thumb right now is 3 generations separated from the original pairing before you bring them back together. I feel like that happens probably in the wild currently, because these hognose snakes don't move, acres and acres away. I imagine they stay in probably the size of maybe 2 football fields for most of their life, 95% of their life. So, that would be good information to know just how closely related they are. But that's probably a completely different type of test as well. I mean, that's pretty extensive. You're going to be looking for, I don't even know what you would look for markers there. I guess it'd be simpler to I don't know, whatever these people are that test your genealogy stuff. It's probably similar to that, but
so there's markers in your DNA that change more often. I guess I think they call them short tandem repeats. So if you, like in forensics, they'll say STR genotyping. But they're markers that change faster than, like, if you look in a gene that's important for that animal to live, those don't change very fast. But these short tandem repeats, sometimes they'll get longer or shorter over a few generations. So we can test a few of those and then give you a readout, say, hey, this one has this length for these 15 different markers. It's something they've been doing with indigo snakes. So they had 17 markers. And so the breeders would be able to look and see, okay, if I'm choosing between these 2 males and these 2 females, I want to pick the 2 that are more unrelated. Then you could look at those markers and be like, okay, this is a 192, 172. This one doesn't have either of those. So, that's just 1 out of the 17. But that gives you a way to pick breeders that are less related to increase your genetic variation. That's what they try to do in zoos as well. They'll try to optimize the genetic variation in their breeders.
I find that very useful because I've been to shows where I've sold animals to those vendors, and then people come to my table trying to buy animals from mine to complete a pairing. And then when I ask them where they get it from, they tell me the vendor, and I said, look, I'm sorry, but his animals or her animals are related to mine, so I don't think it would be a good fit. I'd rather lose a sale, but make sure that they don't run into any issues, because I've been there and I've done that. Yeah. So that would be good, especially for us when we're trying to establish a new gene or a gene that's fairly new. You can get from this person and that person. Unfortunately, the industry has a way of staying hush, and they could have originally came from the same person, and you're thinking you're getting something that's outcrossed, so you could start your foundation, and the next thing you know, they're related, they're cousins, and you're like, okay, well, this is not what I wanted, this is not what I paid bucks for. So it definitely would be something that would be beneficial. I know.
The difficult part right this second for that is to get that at a low enough price that it's feasible. So that's what we're working on for multiple species. That's also the same kind of test you would use for people that want to know purity or locality, or if something is a cross or not. We can answer all of those. Also paternity, we would use that same kind of a test. If there's potentially multiple sires to a clutch, we
That's
could
another
test
good
like, oh, that's that male, that's that male. So
yeah, that's another good one. I've purchased animals from people that had dual sire clutches and they didn't know, and then I bred it specifically wanting the original male, and then the next thing you know, I don't get it, and I'm like, okay, let me ask you a simple question: did you use 2 males? Yeah, I did. I threw in such and such a shell. Okay, and then the following season, I pair up, expecting
Prove it,
and boom, voila.
Yeah, I've done that to myself. I threw a male in, and the clutch came out looking, you know, all of them visually looked like they could have come from that first male. And the other male that went in there didn't lock. So the one that did lock was clown and some other things for ball python. And the one that didn't lock was homozygous for orange dream and negative for clown, no clown in it at all. And so when the babies came out and they all looked like they could have come from that clown male, the one that only had the genes from the mom, I just assumed that also came from him because all the others did. And that's the only lock I saw. And so I bred that female like 4 years in a row. This is before genetic testing. I bred her a bunch of times and I produced her my freaking self. You know, I knew she had to be het clown, but I found out in the end that it was that other male did lock at least one time and he got one. It was like 7 or 8 babies, but that clutch, he only sired one out of that whole clutch. And I bred her a bunch of times, and then eventually I could test her. I was like, oh, she's an OD and she doesn't have clown. She had to come from that other male.
Yeah.
There we go.
It happens.
Yeah.
Oh, yeah. It happens to all of us, man. I know something I try to do inside of my collection when I'm trying to make project animals is either use virgin females. That way I know that they've never, been introduced to another male, or if like, let's say I'm doing something with sunburst, the previous year I used an albino variation of something to make either heterozygous animals or whatnot. I use something that I know doesn't have any type of heterozygous or visual albino in the other side. That way, if I do have an albino that pops up, I know it's retained sperm from the previous year because I mean, I think there was an Eastern Diamondback that produced viable offspring 8 years after being introduced to a male. So
that's crazy.
It's not foolproof after 2 years, but at least your results are less likely to be skewed. So
well, I've had it happen. I've had it happen with chameleons, and I've had it happen with geckos. I've had it happen. The chameleons, I had it 3 seasons in a row. 3 seasons in a row.
That's crazy.
And they're locality specific. So when you mix localities, you're making what you would consider designers. They're less desirable. And the one male that I used on that original female was like he was a wild caught male, fresh. So it was all fresh blood. And I'm like, what the hell is going on here? She keeps laying, and I don't like to deworm or anything unless I know they're done laying, especially with chameleons because they can crash. She just kept laying and laying and laying and laying and laying, and I'm like, all right, 3 years in a row. And then with crested
so
geckos,
amazing.
With crested geckos, and then the crazy part about Rhacodactylus is that you can get parthogenous babies, especially with leachianuses. I would have leachianuses that were females. No male could come close to them. And they'll just keep laying and laying and laying eggs, and they were all female babies. All babies, not temp sex or anything. They were just all female babies because they were all partho babies.
That's cool.
Yeah. That, and I think this is what, like, developing all this science, all this stuff you guys are doing at Rare Genetics is very important for us in the long run, right? There's, I think, Ben, you've probably heard of all the two sides of the coin, right? The negative part and the good parts, but I guess you take the good with the bads, right?
Yeah, if you I find that the people that are later in their breeding career and are not excited about updating their genetics every year, they don't like testing. But people young in their career that are happy to update their genetics and learn and use this as a tool, it can help you catch up a lot faster than you could without it. That's for sure.
Yeah. Before we close it out tonight, Eslyn, any last comments? And then I wanted to ask, if you had to choose three different either recessives or what's it called, incomplete dominant genes that for rare genetics to be able to start testing within the next 12 months, what would they be?
For me personally, I think caramel, Evans, hypo, and lavender would probably be the ones that I would think, and then I would say pink pastel albino as well. I think there's some cool stuff going on with pink pastel albino as well.
Okay. What about Arctic? Any concerns on Arctic?
Arctic is important, of course. There's a lot of times where you breed Arctic and some of the babies look normal. Even with super Arctics, you breed a super Arctic and some of the babies don't look Arctic, but they're Arctic because you bred to a super Arctic and you're like, okay, what's going on here? So Arctic would be probably one of the more important ones, considering it's so popular where so many breedings have Arctic in it, and then it'll be a deciding factor too.
Yeah, and misidentification on them.
Same with Conda, both the incompletes right there on that spectrum. Condas, some of them can be very, very low expression, and you not know it until you hit supers. So I mean, I we're at a point now where I'm not saying it's not important, but it's nice to know. Stuff like that. I would like to see some stuff with some of the newer genes, but a lot of them aren't even established or described yet. So I mean, I think that would be interesting, just seeing how they're being passed. I think that would be interesting. And things like I know Jeff's worked a lot with this, and we've had great discussions about it. He's talked about WOMA. Like, how the hell is WOMA actually being passed along? He's talked about it with me where he can breed 2 WOMA animals, 0 WOMAs, then he'll breed, this other line of WOMAs, and all of them are WOMA, and just how that actual pattern aberrancy is being passed. I've gotten some incredible animals recently over the last few days that are WOMA, but there's 0 of that influenced in any of the breeding, but half the clutch came out looking like that. So it would be interesting to see some of those obscure genes and how they're actually working. Symphony is another one. I know I've talked with Jeff with his symphony line animals. He knows more about it because he's been breeding for a while, but for the layman on the outside, it'd be sure cool to know how that gene's actually working. And how it's being passed on to the next generation. And, he showed some screaming pairs that just over the last day, how they actually were breeding and what's going to come from them. I would love to be, table side to see that. I think that'd be neat. So,
yeah. And Ben, are you guys able to distinguish if, let's say, somebody's been breeding a new genetic, has 2 or 3 generations, are you able to distinguish if it's going to be a recessive or incomplete dominant?
From the genetic data itself, no. So from the genetic data, what we get is we find a mutation that causes a trait, and the test will tell us whether there's 0 copies, 1 copy, or 2 copies. So it doesn't tell us about whether a single copy looks different from 2 copies, or if a single copy looks different from 0.
Yeah.
That in the test, that's not going to tell us. It really is our breeding. But the thing that the test does help is, like in the example with the condas, if okay, these 2 do both test as being het for conda, then okay, I have a chance to make supers. Or you might pick a different one to breed if that one, even though it's not high expression, it is het for conda. That can make a difference. And then, like with orange dream and ball python, sometimes it was hard to tell an orange dream from the super orange dream. And obviously that was helpful to be able to have a test. And if you have 2 really nice looking ones, which one is actually the super OD versus the single copy. So that can help you in your breeding to get more. But as far as making that call, whether something is incomplete dominant or recessive, that's from what we see as the breeders. What comes out the other end, we have to make that call, whether we see this, 3 different phenotypes, or if we just see 2. and that kind of helps us decide whether it's incomplete dominant or recessive.
Gotcha. Okay. So, and I'm gonna close after tonight's conversation and what we've talked about. To me, the top three would be Arctic, Evans Hypo, and Caramel right now. Just
All right.
because trying to finally figuring out, and where we've come to some kind of hypothesis of how this is working. I think those three will be pretty interesting to see. Currently.
Okay, I'm going to redact my statement earlier then as well. I'm going to do some different things. I'm going to do Hypo, Caramel, and Frost.
Yes.
Just see.
Yeah. To see if there's any difference, and that'd be interesting as well. Yeah.
Yep.
So
for sure. So, all right, everybody. All three of you guys, again, thank you guys for spending your time with us tonight, sharing all you guys' knowledge and experience. Definitely looking forward to what everybody has to hatch this year. John, Eslin, Ben, looking forward to what Relatedness has for Hognose this year. So, definitely gonna keep a touch base with you over the next couple of months to see where we're at with that. Everybody within the Hognose community, even if you've got 1 or 2 pairings, send sheds in so we can further along these genetic testing, and I think everybody at the end will benefit in some kind of manner. And if you guys are rewatching the replay, make sure to drop a comment down below if you have any questions, and if I don't answer them, I'll try to get an answer from one of these three. Adam, I did see your your message. I don't think we could differentiate right now. So Adam's asking if caramels will always be het hypo or hypos will be het caramels. I think you'll have to rewatch from the beginning all the examples we showed and see how where the conversation ended. But
and do the breeding.
Yeah, do the breeding.
Figure it out.
There you go.
Yeah, that's the fun part.
Yeah,
and numbers.
Yeah. So again, thank you guys for the night tonight. And everybody that's watching, make sure you like the video and hit the subscribe button. Make sure you guys support us out here, and we'll see you guys on the next one.
Good night, fellas.
Good night, everybody.
10th Planet.